right, you got everybody here? All right, let's go, let's see, all Big Star participants, no homework tonight. And if you come in, let's see, how can we do that? If you come in third place, what, 3 homework passes? Second place? No, let's go 2 homework passes. Second place, 3 homework passes. And first place, what should they get? Winner?
No.
The rest of the year. As long as you got an A.
What's your name?
As long as you got an A. As long as you got an A average. The rest of the year isn't that long. But I reserve the right to at least give you 3 key ones. I'll reserve that right. Does that make sense?
Mm-hmm.
Yeah. All right. So it's official. So what did I say? 2, 3. Third place is 2 homework passes. Second place, 3. Winner, unlimited. As long as you got an A. Okay. Or if you get it up to an A, then you get unlimited. Okay, keep that. All right, I'm fair with that. So, all right, let's finish up. I know you didn't have any homework. We're going to finish up a little bit here. I'm still working on the test. Kind of just doing a page at a time, and for whatever reason, they're not going speedy quick. They're not going speedy quick. So for that one. All right, so we'll talk about here. We'll get to De Moivre's theorem, and we're going to talk about products and quotient. I think that's where we left off. Is that the next piece from yesterday's guided up?
Yeah.
Okay. All right. Good. So product and quotient rules for two complex numbers in polar form. So let Z1 be R1 cosine theta 1 plus I sine theta 1. So Z, let me turn that one on. And then Z sub 2. All right, here are our rules for multiplying, and then here are rules for dividing. Ooh, let's see here. Five, 3.
I tried to explain it to
Okay. Listen up here. All right, so to multiply, you multiply the R values together, add the degrees, add the angles, or argument is called. And I know that was on the tape yesterday. It's called the arguments. When you divide the R values, you subtract the degrees. All right, so for here. So let Z1 equal 3 cosine 65 plus I sine 65. Now this is an IJ form. Okay, these are complex numbers. And one of the things that I told you to take a look at the beginning part of the chapter, I'm sure a few of you did and a few of you didn't, which is fine. Complex numbers come up in electrical engineering. Okay. Sometimes if you're going to take that path, you will study them in some detail. I had to take a complex analysis class when I was getting my master's, which is complex analysis of all complex numbers. And about half the people in there were electrical engineering majors. Okay, so a lot of those, like I said, it comes up in their field a good bit. So for this case here, Z1 times Z2. Let's multiply those two together. So Z1 times Z2. The process here, as long as you remember, it isn't hard. Multiply 3 times 4. And then you're going to take cosine of 65 plus 15 degrees. I'm just going to show it here for the notes. Plus I sine of 65 plus 15. And then simplify that to 12 cosine 80 degrees plus I sine 80 degrees. Multiply your R's together, add your degrees. Okay, that's all you do for that one. For Z1 divided by Z2, you divide your R's, and that's going to give us 3 over 4. And then it's going to be cosine, subtract what do we get there? 65 minus 15. I'm just going to subtract it. Was that 50 degrees? 50 degrees plus I sine of 50 degrees. So that's 65 minus 15. 65 minus 15. Okay, for that. On that case. Now, I know I didn't say it in the directions, but you don't always have to do Z1 divided by Z2. You can divide the other way. So I want to show you something. What does Z2 divided by Z1 look like? Z2 divided by Z1, that's going to be 4 over 3. Cosine of what, though? What we got to subtract in that order, so it's going to be 15 minus 65, which is what?
310. Well, it's negative 50.
So then I'm going to start with that. You're right, but I'm going to start with that. Negative cosine of, so when you subtract, it's going to be negative 50 plus I sine of negative 50. More often than not every time, but like that's going to be, should be converted to a positive angle. So I want you to see that it's written as 310. Like Cooper said, that's normally how it's going to be written. So it's going to be 4/3 cosine of 310 plus I sine of 310. Okay. Cosine 310 plus I sine 310. All right, so it doesn't matter. You can divide Z1 divided by Z2. You can divide Z2 divided by Z1. Okay, for that. Now, hold on. I said leave the answers in polar form. That's easier, obviously, because you just add those angles. Now, this one says write the answer in rectangular form. All right, we're only going to do Z1 divided by Z2. But we're going to, in the end, convert to rectangular form. All right, go ahead and do Z1 divided by Z2. You got to do it polar first. Like keep your Z values in polar. Don't convert those rectangular at this point. So Z1 over Z2 is going to equal 12 over 4, which reduces to 3. Cosine of 220 minus 40 is 180 plus I sine of 180. If it's a unit circle angle, convert it to exact form. If it would be like 150 or 128 degrees, you'd have to use your calculator. But cosine of 180 is -1 plus I sine of 180. What's sine of 180? 0. So in the end, what does Z1 divided by Z2 boil down to? -3. Okay, so we started with two complex numbers. We divided them, and we just got a real number. Okay, they both had an I part. Now there's just -3. Okay, for that one. All right, so that's adding and subtracting. All right, let's take a look at that next set. We're going to go just over a couple of things. We're going to basically this first part here. De Moivre's theorem. And there's a couple of different forms of it. We're going to do this first form of it here. All right, let Z equal R cosine theta plus I sine theta be a complex number in polar form. All right, if you are doing a power, it will simplify to the following. R to the n power, just multiply n times theta, n times theta. If you would just think of repeated multiplication, it'd be the same thing because you're going to keep multiplying the r's together, and then you would add theta however many times the power is. So you're basically just going to multiply n times theta. So for this case here, all right, use de Moivre's theorem to find each power of z. Write the answers in rectangular form. So it's like use it first, then when you're done, convert it back to rectangular. All right, square root of 5. This one's in radians. Keep it in radians to begin with. So here's what you're going to do. Z to the 8th power. Okay, or square root of 5. This is going to become square root of 5 to the 8th. Cosine of 8 times pi over 4 plus I sine of 8 times pi over 4, and then square root of 5 to the 8. Somebody help me out. 625? Yes. 625. Cosine. Okay, 8 times pi over 4 is going to become 2 pi plus I sine of 8 times pi over 4, which is 2 pi. And now we want to figure out what cosine of 2 pi is, what sine of 2 pi is. And so we're going to get 625. Cosine of 2 pi, which is 360 degrees, is going to be 1, plus I times sine of that is 0. So in the end, that becomes just 625. Okay, so that power, so that number to the 8th power ends up being just a real number with no imaginary part. Okay, and let's take a look at part B there. All right, z equals 2 minus 2i. Find z the negative 4th power. You're going to want to convert that to polar form. So take z equals 2 minus 2i, convert that to polar form. Now that's from yesterday, so see what you remember from yesterday. Your r is going to equal the square root of 2 squared plus negative 2 squared. So it's square root of 8. I'm not going to reduce that at this point. I'm just going to leave it at square root of 8. Okay, what quadrant is 2 minus 2i? It's in quadrant 4. So you got to know where our final direction is going to be. So this is our reference angle, is inverse tangent, absolute value of 2 over 2, which just reduces to what? 1. So what's our, if you do the inverse tangent of that, you're going to get 45. So that's my reference angle. So that's 45 degrees. So it's going to be 315 when we're done. So z equals square root of 8 cosine 315 plus I times the sine of 315 for that. All right, what power are we asked to find? Z to the negative 4th, right? Okay, so let's follow our rules. Z to the negative 4th is going to be square root of 8 to the negative 4th cosine of negative 4 times 315 plus I sine of negative 4 times 315. All right, square root of 8 to the negative 4th. I'm just going to kind of do this over here. Remember, that is 1 over square root of 8 to the 4th. We don't want to like if you just type that in your calculator, it's probably going to give you some decimal. Let's not do that. So to make it 1 over radical 8 to the 4th. Now do radical 8 to the 4th power. Okay, so square root of 8 times square root of 8 times square root of 8 should give you 64. Okay, so really, radical 8 to the negative 4th is 1 over 64. So we got that. Cosine, all right, negative 4 to the 315 times 315, is that negative 1260? So negative 1260 plus I sine of negative 1260 All right, now go ahead and I would find the coterminal angle. I would just add 360 till you get a positive angle, unless you know where negative 1260 is at. It's going to end up being a decent angle, if I remember right. Let me just get my calculator out real quick. Emily, what's it end up? What's it end up equal? 180. All right, negative 1260 plus 360 plus 360 plus 360 and plus 360. So it's coterminal angle is 180. But we're going to end up, I do want this in the end in rectangular form. So z to the negative fourth equals 1 over 64 cosine of 180 plus I sine of 180. So cosine of 180 is negative 1 plus sine of 180 is 0. And so you're going to end up with negative 1 over 64. Now, not in every case does the i's drop out. I know they have in the last couple. Okay, but don't assume that that's going to happen on every one of them. Okay, for that. All right, I wanted to give you guys time because you guys are meet you full period. So you can start on the homework here. Oh, where did it go? There it is. All right. You're doing it's a great start. I got a extra problem for you to practice. So who's in? And